my keynote will be about affective robotics and nudge and ethical issues. So next slide. So I'm professor in artificial intelligence at Sorbonne University at CNRS and a human-machine affective interaction specialist. I was involved in the JPI as expert in the group of Future of Work. I'm now convener of the working group 4 on foundational and societal aspects of artificial intelligence at the GTC 21, which is devoted to the artificial intelligence standardization at the Sensenelec organization. So this group has in charge several topics, including AI-enhanced nudge, processiness AI, green AI, and also augmented AI. Next slide, please. So I'm a researcher at the CNRS at Saclay, Paris-Saclay. So I'm working on the affective and social dimension of spoken interaction with robots or chatbots. Since 2004, my team is composed of 5 to 10 researchers with a lot of PhD. And we work on detection of emotion, dialogue system, dynamic speaker profile modeling, and also ethical issues. And this focus today, specifically, I will focus on nudging with affective computing. So next slide, please. So first, some few definitions, but I think that you are expert, but sorry for that. Robot is physically embodied, but must have several types of AI models to develop perceptive decision-making and reactive capabilities. And socio-affective robots interact with humans using language and affective scales. So a conversational agent is a machine that interacts with user in natural language, usually integrated into a digital platform like a robot or embodied virtual agent with at least 3 components: the perceptive component, speech analytics and automatic speech recognition, then semantic analysis and dialogue policies, and at least response generation and speech synthesis. Next slide. So I'm working on affective computing related to the work of Rosalind Picard in 1997. And there is 3 technologies. The first is emotion detection from the subject behavior, understanding and reasoning with the cues we detect, and then generate emotion and synthesize this emotion. So emotion is a key explanatory factor of behavior, and Antonio Damasio explained very well in this book, The Error of Descartes, who are not rational without being emotional. Next slide, please. So emotion play a central role in social interaction, and we measure this emotion using different kind of captors, sensors. So in my lab, we mainly use voice cues, visual cues, and physiological cues. And lastly, we use eye tracking detector also. And there are not grand truths. The mix of these cues are very essential to detect emotions. So multimodal aspects of emotion are very important. And currently, the challenge is how we are able to fusion the different types of information we collect with different data sensors. Next slide, please. The topic of modelization of language is a huge topic now. But human language is an essential element in shaping, even determining cultural characteristics, human perception, and even entire worldviews. So emerging interactive and adaptive system using emotion and language modify how we will socialize with machines. And these areas inspire critical questions centering on the ethics, the goals, and the deployment of innovative products that can change our lives and society. People tend to respond to embodied agent and robots, social robots, as they would either to another person by being polite, cooperative, attributing personality characteristics such as aggressiveness, humor, expertise, and even gender, depending on the cues they receive from the media. So the embodied agent robot can inspire empathy if it's him in the pain. So next slide. At LESN, in my lab at Saclay, we create social robots using conversational agents that can recognize, interpret, process, and simulate human language and affect. And we did a lot of experiments also about humor, detecting laughter. And with the capacity of interpretation of the emotional state of humans, a robot can adapt his behavior and give an appropriate response to these emotions. So naturally, it interacts differently with different individuals. Next slide, please. So we did a lot of tests with the objective to collect realistic data, real-life data, and trying to make some real experiments with people that can use this kind of machine. For example, at Broca Hospital, or also in retirement home, we did a lot of experiments, such as a kind of scenario, the robot negotiates for that the person drink a glass of water, and if the person doesn't want, the robot adapts its policies. So next slide. So I think that we have a real voice technology revolution currently, and this new area of voice-enabled devices and that rapid adoption signals a major shift for the digital world and consumer interaction models, with the potential to augment human welfare and well-being in many ways. We can improve the customer experience, personalize the communication, as with robots, give medical advice, help elderly, create a virtual companion, and so on. But these socio-affective robots can have also negative consequences, unfair or manipulation, if not regulated. So we need to build trustworthiness within a sustainable market. Next slide, please. So I begin to try to understand the concept of nudge. So the nudge is a technique that consists in encouraging individuals to change their behavior without constraining them, using their cognitive bias, for example, lacking self-control, acting emotionally, acting by conformity or laziness. And this is based on the work of Richard Thaler and Sustain. Richard Thaler obtained the Nobel Prize in Economics in 2017. So nudge I mentioned a specific text from Thaler and Sustain. Any aspect of the choice architecture that alters people's behavior in a predictable way without forbidding any options or significantly changing their economic incentives. To count as a mere nudge, the intervention must be easy and cheap to avoid. Could you change the slide? So the key insight is the fact that user interface design influences choice, even unintentionally, and heuristic and bias influence offline and online behavior, and through design and testing can help achieve a designer's intended behavioral effect. So it's a great power with this kind of socio-affective machine to use this nudge strategy. So I obtained a chair, which is, the name is Human-Machine Affective Interaction and Ethics, about this nudge. So the idea is to try to find how we can audit and measure the potential influence of affective spoken system on human and nudging system interaction, and also relationship in different domains such as education, health, and so on. Could you change the slide, please? So to define more what is nudging. Nudging mechanism is a subtle changes in the choice architecture that can be the way of the agent or robot answer to a question that can alter people's behaviors in predictable ways. So there is the nudge, which is well known. The idea is to encourage shift in behavior based on bias, but the contrary is a sludge. It's the mechanism to add friction in making a choice based on bias. So digital nudge and sludge use familiar online technologies such as email, pop-ups, SMS, web interfaces, IoT, chatbots, video games, social robots, embodied agents, so on. So socio-affective robots could encourage a user to do, for example, more sports by referring to the example of their athletic frames. So there is a lot of tools that use currently the nudge strategy. Could you change the slide, please? So what is AI-enhanced nudging device? It could be a robot, a voice assistant device, a personalized system, or just an AI system that perceives your behavior or emotion and subtly modifies the architecture of choice, the recommendation system, or other interactive system in order to influence your decision or action. So the massification of harmful consequences of AI-enhanced nudging, even with no bad intention, could have a lot of ethical issues. So we recommend to design standards and to audit the usage of this kind of machine. The consequence could be addictive products for vulnerable people, such as children, for example. So AI-enhanced nudging in the robotics open new ethical challenges, such as emotion manipulation, confusion between reality and reality, I mean, in virtual reality, for example, and relationship with digital objects. And for another example, the fact that the feminization of the voice assistant devices, which are more globally feminine voice, feminine face, or appearance of robots, is a way of nudging people, with the direct consequences of the amplification of the stereotypes of gender. So another recommendation could be randomization of the gender choice. So next slide, please. I continue to explain about this problem of gender choice. So when we design social robots, we bring new dimensions, similar language, similar body movement, or affective behavior to the interaction. And this could be a mean of influencing or nudging individuals. And as I mentioned, there is a real problem of discrimination. 80% of the coders are men. 80% of this kind of system build have women names and women face and body. Generally, these robots are assistants, nurse, sexual robots. So AI system reinforce the stereotypes. So it's important to understand that we need regulation on or standard on this kind of things. Next slide. So in my share, we have several objectives. The first main research objective is a focus on socio-affective state detection from paralinguistic and linguistic cues and also visual cues using deep learning techniques. And we explore time attention mechanism and fusion using attention and transformers for multimodal emotion recognition in real-life dialogues. The second axis of research is about nudging system using hybrid symbolic and deep learning, deep reinforcement learning, and adaptive learning. So this idea is with using zero-shot training algorithm to be able to build a system that can adapt to the people and learn what is the best strategy for nudging you. The third axis is a focus on experiments in real use cases. And we made experiments, for example, at primary school, comparing the efficacy of both positive and negative linguistic nudge with children, but also on a subject about environmental attitudes. And we have two projects about nudge in education. The last research axis, or it's much more about mediation, how we can disseminate these results and explain more of the methodology of all these experiments and how we can provide from research a lot of evaluation metrics that could be useful for normalization of this kind of system. And I'm working currently with a college of the Bernardin in Paris and with this group of GTC 21, and I will explain more later. Next slide. So the experiment at school was with robots, and also we compare, in fact, the influence of nudge using a conversational machine like a Google Home, a social robot, and a human. Each setup includes a detector game adapted to children, from which we can infer a nudge metric. And the first result from the detector game highlights that the conversational agent and the robot seem more influential in nudging children than an adult. So this is quite interesting to show this kind of results, and we would like to improve this result using a more experiment with a larger set of participants. In this case, we have done this experiment with 90 children from this primary school with different levels. And another result is the fact that the younger children was more easily nudged. Next slide, please. So another experiment was made in the Collège des Bernardins, with the Collège des Bernardins. And we went to investigate the potential of influence by a robot, smart speaker, and human agents, same methodology, and use nudge with positive and negative influences. It's linguistic nudge. And these linguistic nudge are defined as information that indirectly steers a person to adopt a habit by presenting positive side of the consequence of this habit. And nudges with negative influence focus on information about the negative side of a habit outcomes, pushing a person to not adopt this habit. And the first experiment was done with 49 French native participants, recorded in the Collège des Bernardins in Paris. And we show that participants react differently to agents and also have some result about the polarity of nudge. Some result, for example, a machine agent can influence participants To the same degree as a human agent, participants were mainly affected by the nudge with positive influence. Participants were willing to spend more money than time on ecological problems, and the group with negative influence was ready to spend more time on ecological problems than the group with positive influence. We have done more experiments now, but we have not currently the results. So we have now more than 100 people that participate to this experiment at the Collège des Bernardins. Next slide, please. So I'm also involved in several projects about nudge. For example, learning cyclotron with German researchers and Japanese researchers from Osaka and DFTKI for Germany. There's three stages of learning cycle: perception, mastering, transfer of knowledge. The task here is to learn English, and we use features from eye tracking and speech. And the goal is to use nudge to improve the three learning stages. So we have several first papers, and now Sofia is in Japan to learn more about visual features, also trying to use eye tracking, speech and visual features. And the next step will be to use nudges to improve the learning stage. Next slide, please. We also have a French project with the industry named EduWinky. And the idea is also to learn English with a little robot, Winky, which is able to react to the child's performance and try to nudge the child. So we try to experiment sequence of nudge and sludge, as you see in the slide. So there's a sludge, nudge, and then reward, or different kind of policies used. And then we have not collect enough data for the moment to analyze, but it is in progress. So this is this idea of sequence of different kind of nudge and sludge are very interesting to push people in learning process. Next slide, please. So we mentioned this project. We did a US project, MOXIE, so a kind of AI-enhanced nudging for autistic children. It's easy to find a video about this project. It's quite interesting. Children are engaging into creative play with the robot MOXIE, drawing, storytelling, mindfulness practice, and more that helps promote an important life skills such as conversation, talking, emotion regulation, and how to make friends. MOXIE can learn to recognize a child's face and their particular learning needs for nudging. AI-enhanced nudging's persuasive power and intrusive capacity can also cause profound and long-lasting changes in the behavior of users, such as isolation, addiction, and especially with children and vulnerable people. So this is already used, but I think that we need to be careful about this kind of tool. Next slide. So about vulnerabilities, all observable and observed human behavior is a result of cognitive bias, false priors, anchoring bias, emotional bias, and so on, which can be exploited by machine to modify the behavior. AI-enhanced nudging's persuasive power and intrusive capacity can also cause subliminal manipulation and profound and long-lasting changes in the behavior of users, such as isolation, addiction, as I mentioned previously. So AI-enhanced nudging mechanism may become dangerous or raise serious ethical issues that can undermine the level of trust in the robots or cause detrimental changes to the society, the environment, and the market. Next slide. So it's important to understand also that there is a clear asymmetry of knowledge and power between humans and human experts in AI and humans that are not expert at all. And also, I mentioned a lot human-machine co-adaptation, co-evolution. We will change our behavior. We are building as engineer machines that are able to adapt to the behavior of the person in front of the machine, but we will also adapt our behavior to the machine. So how we will co-evaluate with the machine is a high topic. The change of relationship to the world, knowledge, emotions, interpersonal relations, the relation between virtual and real are real open questions. So how to anticipate this development and the condition our free will, understanding of the digital, it's important. So next slide. We have to identify ethical risk related to the use of these AI-enhanced nudge sludge. Nudge and sludge may be natural or may become only pretty disturbances, but some nudge can have a deleterious influence on children, protected group, or any user in a period of emotional fragility. Risk may range from a variety of reasons. So, however, it's still not known whether long-term exposure may increase the severity of damage. There is not a lot of research on long-term experiments. So we have to investigate long-term effect of nudges. This is an urgent topic. Next slide. If you have read the AI Act proposal about regulation of AI, they mention in Article 5 that the AI system that deploys subliminal techniques beyond a person's consciousness with the objective to or the effect of in order to materially distorting a person's behavior in a manner that causes or is reasonably likely to cause that person or another person physical or psychological harm will be prohibited. But first, it's not obvious to detect this kind of mechanism. And there's a lot of case that's in a gray zone. So we have to build this standardization of this kind of machine to be able to audit the system and measure the ethical rules or risk. Next slide, please. So I'm involved in a ad hoc group in AFNOR and now GTC 21. And this about AI enhanced nudge. Our objectives are to define clearly the mechanisms, redefine nudge and sludge concept, help the industry to mitigate risk related to AI enhanced nudging mechanisms, and define residual risk. There is no 0% risk, as you know, so we have to define this residual risk. Identification also of risk in use case for humans and society at the two levels. And also the idea is to create and introduce a methodology for impact assessment, risk mitigation, and metrics designation, and to propose to build an adapted, diverse input and multi-stakeholders ecosystem, an ethical infrastructure to judge this kind of results and measure that and audit on the different system. So the way to build a standard is large discussion in Europe, at Europe level, with a lot of experts coming from mainly from industry, but also some researchers are also involved. So it's quite interesting to discuss this point, to try to find a balanced vision, and also a clear common objective. Next slide, please. So our methodology for impact assessment, risk mitigation, and metrics designation, if I can make an analogy, is like in the medical sector. AI providers can set up processes to ensure that serious incidents are identified and assessed. This enables developers and AI designers to be alerted to signals emerging across the world, which might not be obvious from local data alone. Metric designation, we can identify processes and key indicators, both horizontally by industry and sectors, and vertically by applications and technologies, supporting AI-enhanced nudges requirements in order to develop conformity assessment methodologies and tools. Next slide. So to conclude, the issues surrounding the human-robot interaction cover a wide range of ethical topics, as you know, censorship of content, discrimination, and fairness. I focus today about manipulation, soft manipulation, like nudge, that can change our collective behaviors and cultures also. How will humans co-evolve, co-create, co-learn with these socio-affective robots at work, for education, for health? In particular, how will vulnerable people be protected from potential threats? A lot of use cases can lead at ethical positive nudge, such as areas of health, consumer goods and services, and green energy. But nudging poses an ethical threat and negative business implications. Socio-affective robots using AI-enhanced nudge raise ethical questions to which no standard today provides direct answers. So we must define these standards and ethical frameworks, soft law, for socio-affective robots and educate multidisciplinary and multi-stakeholder. Next slide. I thank you for your attention. If you want to discuss more these topics, please contact me. And it was a pleasure to show you this kind of information. I'm sure that the workshop is really interesting, and I'm so sorry to not be with you to discuss more this topic with you. Thank you.